Okay, so what we're going to look at today is finding zeros of polynomials, and we have worked with factorable ones, like quadratics, but now we're going to look at higher degree, and we are going to use the rational zero test, and the rational zero test says that we take p divided by q, okay, and p then is a factor of the constant term. So take a look at this polynomial that's written up here. This is the way you'll see it in the book, and it looks like a lot of technical writing, but the a sub o is the constant term. So see, it doesn't have an x with it. And the a sub n is the leading coefficient. So we only need those two pieces of the polynomial to figure out the rational zeros. So p is a factor of the constant term, so the a sub o is the constant term. That is in the numerator. And the q is a factor of the leading coefficient. So those factors go in the denominator. Well, let's try it with these polynomials here. So on the first one, remember I only need the constant term. So the constant term is 8. And the leading coefficient, which is 1. So the constant term is the p, so those factors of 8 go in the numerator. So our factors of 8 are plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. And then we've got to take those numbers and divide them by our coefficients, our factors of our leading coefficient, which are 1. Well, if I divide by 1, it doesn't change those values. All right, let's go to the second one. Here's the constant term is 8, and our leading coefficient is 2. So we want to take the factors of the constant term, so it's exactly what we had on the last one, plus or minus 2, 4, and 8. And we also then want to take those, we want to divide them by factors of the leading coefficient. Well, the factors are 1, so if we divide by 1, those stay the same, and then we have to divide each of them by 2. So 1 divided by 2 is going to add 1/2. But 2 divided by 2 is 1. It's already listed. 4 divided by 2 is 2. It's listed. 8 divided by 2 is 4. So those are our possible rational zeros for that polynomial. The third one, here's the constant term, so I need factors of that, so plus or minus 1, 2, and 4. Then I need to divide them by factors of the leading coefficient. The leading coefficient here is 2. So 1 divided by 2 is 1/2. But 2 divided by 2, we already have the 1, 4 divided by 2. Okay, so those are our only possible rational zeros. Now you kind of have to be careful. Look on this last one. My constant term is -7, so the factors of -7 are 1 and 7. But the leading coefficient is not the first coefficient that you see. It's the coefficient of the term with the highest degree. So here's our highest degree. This is the third degree. So our leading coefficient is 3. So we have to divide the factors of the p, the -7, by the 3. So I need 1 divided by 3, and we would also have to add in 7 divided by 3. So those are, once again, the possible rational zeros. All right, the rational zero test with the leading coefficient. So what we're going to do here is we're just going to find the rational zeros. We're just going to find the rational zeros of this polynomial. And we want to know, we're going to take the possible ones and then see which ones work. Okay, so our possibilities, we go to the constant term. So we have a 12. So we have to list all of those factors of 12. So I've got plus or minus 1, 2, 3, 4, 6, 4, 6, and 12. Our leading coefficient is just 1, so we won't have any fractional ones. They end up being all integer ones. So now we need to see which ones work. So this is where we're going to have the calculator help us. So we're going to plug that polynomial into the calculator. So you go to your y equal, put in x to the 4th minus 7x cubed. So you're just going to put that whole polynomial in there. And what we're going to do, instead of doing the rational zero test, instead of doing synthetic division on all of those numbers, because that's a lot of them, we're going to look to see where it looks like it's crossing, and that will help us out. It'll minimize our workload here. All right, so we want to look at the graph. And here it comes. All right, so it looks like it is crossing at 2 and 3. All right, so of the possible ones, we are going to, let's start off with 2. So we're going to use synthetic division. We're going to put 2 on the shelf. So our coefficients then, make sure they're in descending powers. Make sure that we don't need any placeholders. So 1, -7, 18, -22, and 12. Okay, we bring down that leading coefficient of 1, multiply, and we add there, so -5, multiply by the number on the shelf, add, multiply 16, add, and then we get -12, and sure enough, it is a 0 because we got a remainder of 0 there. Okay, so now we're going to take, they call it the depressed equation here. So we went from a 4th degree to a cubic, and now we're going to try our other one from the graph. It looks like it's crossing at 3. So we're going to put 3 on the shelf, bring down the 1, multiply, and so what we're looking for is a remainder of 0. And sure enough, we get a remainder of 0. So the rational zero test then tells us that of our possibilities here, 2 and 3 are zeros. And if I take a look then at what we have left, this is a quadratic, so we'd have x squared minus 2x plus 2. Well, the only way we'd have any more rational zeros is if that would factor. And when you look to factor that, we would need factors of 2, positive 2. So we'd have to have a 2 and a 1. That would have to add up to a -2. Well, they'd both have to be positive or both negative, but because this term is negative, we need both negative. And note, that would give us a -3x. So because it does not factor, it doesn't have any more rational zeros. So yes, we have 4 zeros. 2 of the zeros are rational, just 2 and 3. Okay, let's try. We want to find all the rational zeros of this function. So once again, we are going to take a look at our constant term. So we have -10, our factors of -10, plus or minus 1, 2, 5, and 10. Our leading coefficient, take a look at that. The leading coefficient, so the highest power here is the 3, so the leading coefficient is 1. If I divide those by 1, we don't add any other roots. So I'm going to graph that to get some help. Because I don't, that's only 4 of them to try, but still, it's easier just to use that calculator to give you that graph, so we can look to see if it looks like it's crossing at any of those points. All right, and then the graph, take a look at that. Okay, well, it looks like we've got a -2 and a -1 and a 5. All right, so let's do our synthetic division then. Let's start off with the -1. We're going to put -1 on the shelf, bring down our coefficients, and see if we get a remainder of 0. So 1, -1, -3, 3, -10, positive 10. Yes, we get a remainder of 0. Okay, so now we're going to take another one of them, so it looks like -2, so let's put -2 on the shelf. 1, -2 will give us a -5. When you multiply, we get positive 10. Yep, so -2. And then what we have left is a linear factor then. So we have x minus 5 as a factor. So that means then our other 0 is 5. So our rational zeros, all of looking at our possibilities, we had 8 possibilities, And the ones that actually worked were -1, -2, and +5. The rational zero test with the leading coefficient other than 1. All right, so we've been looking at some where we didn't have any other possible zeros with that leading coefficient of 1. On this one, we go to the constant term. We always start with that. Factors of 3 are 1 and 3. But I have to divide by factors of the leading coefficient. So factors of 2 are 1 and 2. Divide by 1, no more. If we divide by 2, we'd get 1 divided by 2, and we would also get 3 divided by 2. Okay, so we are going to go to the calculator then and see which ones of those might work. So when we graph it here, it looks like, well, it looks like it's crossing at -3. So let's put -3 on the shelf. So we've got 2, 3, -8, and 3. So we get 2, -6, -3, 9. Now what I'm going to do here, because I got that remainder of 0, so we know that -3 is a 0, but let's take a look at what's left here. We have 2x squared minus 3x plus 1. Okay, and we see our roots over there. It looks like we have other ones, but let's try and factor this one instead of using synthetic again. So 2x squared, we'd have to have a 2x and an x. Factors of 1 are going to be 1 and 1. The signs, because it's a positive here and a negative here, they'd both have to be negative. So here I get a -1x, here I get a -2x, which gives us that -3x for a middle term. So the x minus 3 was a root, or the -3 is a root, so x plus 3 is a factor. So these would be the factors of that polynomial, whereas our roots would be -3, +1/2, and +1. And if you look at your calculator, you can see those. All right? Okay. The next one, rational zero test, here again with the leading coefficient other than 1. So, is that the one we just did? Okay, so we are going to take a look at the factors of the constant term, so plus or minus 1 and 3, and then divided by the 2, so plus or minus 1/2, plus or minus 3/2. Okay, we're going to go to the calculator. Oh, and we did that one. So let's just move on to the next one. We already did that one, so that screen came up again. So let's go to 7 here. Sorry. Here we go. So our leading coefficient here is 1. Leading coefficient is 1. And then our constant term is 8. So factors of 8 then. So we just need plus or minus 1, 2, 4, and 8. Okay, we're going to look to see from the graph then where it looks like it might cross. So we're going to plug that into the calculator. Okay, we go to the graph. All right, we've got, looks like it's crossing at -2. So let's verify that. Let's put -2 on the shelf. We've got 1, 1. Oh, whoops. Okay, let's try that again. So we're going to put -2 on the shelf. Now this one, I've got the leading coefficient is 1. Notice there's not an x to the 4th, so we need to put a placeholder in there. And then 1, 2, negative 12, and 8. See, we got a lot of numbers to deal with here. So bring down the 1, multiply, add, multiply, add. So once again, we're looking for a remainder of 0. So negative 8, there we get it. So 2 is one of our rational zeros. And then it looks like 1, so I'm going to take the depressed polynomial. I'm going to put a 1 out on the shelf. So 1, 1, negative 1, negative 1, 4, 4, negative 4, negative 4, and 0. Now, because it's tangent there, then 1 is possibly a double root. You know, it's kind of hard to tell from the graph unless you zoom in on it, but it kind of looks like it's tangent at 1. So we're going to put 1 on the shelf. Oh, I guess I put it kind of low. So we bring down 1. 1 times 1 is 1. 0, 0, 4. So there we get our other one. So 1 is a double root, negative 2 is a root, and we're left with a quadratic now. So we have x squared plus 0x plus 4. Okay, so this one says find all the zeros, not just the rational ones. So we got to take this guy and solve it also. Well, on this particular one then, we can move the 4 over. So it's equal to a negative 4. Take the square root. So we get plus or minus the square root of negative 4, which would be plus or minus 2i. So plus or minus 2i, we have 2 imaginary roots, and then we have 1 is a double root, and negative 2. So there are all 5 of our roots. This one says we're going to kind of work it backwards. Find a 4th degree polynomial function with real coefficients 2, negative 1, and 2i as zeros. So 4th degree means we have 4 roots. They gave us 3 of them here. But remember that complex zeros always come in conjugate pairs. So if 2i is a root, that means negative 2i is also a root. Okay, if those are our roots, then we're going to set up our factors. So our factors are going to be x minus 2, x plus 1, x minus 2i, and x plus 2i. So to get the polynomial, we now have to multiply that out. So let's multiply the last 2 together first of all. So x times x is x squared. I'll have here when I multiply these, the outside terms, I get a 2ix, and here I get a negative 2ix. So that cancels. Then I want to take negative 2i times positive 2i, so we get negative 4i squared. Remember, I squared is a negative 1. So this then, negative 4 times negative 1, this will change to x squared plus 4. And we just did the problem, that last one, where we had x squared plus 4 as a factor, and we solved it, remember, and got plus or minus 2i. Then let's multiply the first 2 together. So we'd get x squared minus 2x plus 1x will give us a minus x then when we combine those middle terms, minus 2. So now the last thing is to multiply these 2 factors together, this one and this one. Okay, so we're going to take x squared, we're going to distribute x squared. So we get x to the 4th plus 4x squared. Now we're going to distribute the negative x. So negative x to the 3rd minus 4x. And then now we're going to distribute the negative 2. So minus 2x squared minus 8. We'll combine it all, so our leading term is going to be x to the 4th. There's only one x cubed there. 4x squared minus 2x squared is plus 2x squared. Minus 4x minus 8. So there is our 4th degree polynomial with those numbers that they gave us as the roots. Okay, so here's one I want you to try then. So see if you can find the zeros of this. This will be one that you can try on your own. Use your graphing calculator to help you out with that. And good job. You guys have done a nice job. So that was a lot of information. And we will practice some more in class. See you there.